This video is about C2 and C3, charge carriers. Now, both these topics are so similar, we'll treat both of them at the same time. Now, to start off, we talk about the charge per electron. If I know the total amount of charge, we can call that Q, and I know the total number of electrons, we can call that N, and the charge per electron is E, and E works out to be negative 1.60 times 10 to the negative 19 coulombs to three significant figures. Now, the amount of charge that passes a point on a circuit per unit time we call the current. Charge is measured in coulombs and current is measured in amperes. If I have current flowing through a cable like this, and the current is 1 amp, 2 amps, 3 amps, some current that we might be able to measure in a lab, the electrons themselves are moving in the opposite direction. Not all of them, just those that are free to move. We call those the free electrons, and these are moving in the opposite direction. And it turns out that they drift very slowly through this wire. They're moving very quickly from atom to atom, these conduction electrons, but they drift very, very slowly with a speed that we call the drift velocity. Now, if I have a volume of wire here drawn, which I will label V, that's the volume of that wire, then the number of electrons divided by that volume we can call the electron density. And I'll use the symbol lowercase n to indicate electron density. Typically for a metal these would be in the order of 10 to the 29 or 10 to the 26 or this sort of large number of free electrons per unit volume. So the unit of this would be the meter to the negative 3 per unit volume. So the total amount of charge that can possibly flow from one point on the wire to the other point in 1 unit time would be Q. And so Q is the total number of electrons multiplied by the charge per electron, which we can see from this is equal to the free electron density multiplied by the volume and multiplied by the charge on each electron. Because Q is the total amount of charge that flows in 1 unit time, we can say this is the current multiplied by the time that the charge takes to flow. Now let's call the distance between the two ends of the wire L, and the cross-sectional area of the wire A. That makes the volume of the wire V equal to A multiplied by L. And we can substitute this into the equation. So we have N, the electron density, multiplied by A, the cross-sectional area, multiplied by L, the length of the wire, multiplied by E, the charge on each electron, equals I, the current, multiplied by T. And I can rearrange this a step further, and I can say that L divided by T, that's the total distance from one side of the wire to the other, divided by T, the time it takes for all of the charge to flow, is going to be equal to the current divided by the electron density, the free electron density, divided by the cross-sectional area, and divided by the charge on each electron. Now we call that the drift velocity. That is the average speed that an electron will drift from one side of that wire to the other. And it's not very big at all. To give you an example, if we have a 1 ampere current flowing through the wire, we know that the charge on the electron is 1.60 multiplied by 10 to the negative 19 coulombs. We can say the area, the cross-sectional area of the wire, is about 8 times 10 to the negative 7 square meters. That's approximately 1 millimeter in diameter, so it's a pretty thick wire. We can say that the number of electrons per unit volume in our wire, let's pick copper, so that's 10 to the 29 free electrons per cubic meter. And we substitute these numbers into this expression, we get a drift velocity, which is approximately in the order of 8 times 10 to the negative 6 meters per second. So that is about 8 micrometers per second. Very, very small drift velocity. Now, there are only two things that can complicate these questions. The first is how you calculate the area, And the area could be given as a cross-sectional area, or you may have to calculate it from either pi r squared or from a quarter pi d squared. Just be careful that you convert your radius or diameter into meters first, because your free electron density is given in number of electrons per unit volume, so per cubic meter. And the second thing is to be aware of ions. So an ion, for example, Al3+, has a charge of positive 3 times the elemental charge, or a charge per particle, so per ion, of 3 times 1.60 times 10 to the negative 19 coulombs. Especially in C3, you won't necessarily be talking about electrons flowing, you'll be talking about ions flowing. So just bear in mind you'll have to calculate the charge of each ion to work out how much charge is flowing in total, or to work out how many ions are flowing in total.